Hey everybody, hope you're doing well, and I hope you had a great Memorial Day weekend. I hope the weather was okay, and speaking of weather, that is the subject for today. You ever wonder how meteorologists forecast the weather? I do too. Uh, we know they have a lot of technology at their disposal, things like satellites and radar, that gives them digital readouts of cloud cover and rain. But they also look at specific measurements that are kind of low tech, so to speak, and that's going to go a great distance toward meteorologists forecasting or predicting what the weather is going to be. Now, whether you're interested in the weather or not, everybody wants the type of weather for the activities they're going to do outside. So it seems like even if you're not into science, you still kind of pay attention to the weather, and you're always hoping it's going to be something, whatever that is: warmer, colder, rainy, sunny, windy, or calm. Well, a science lesson wouldn't be complete without a joke. Yeah, that's a classic. So, with all this technology at their disposal, the satellites and the radar and all the high tech gadgetry, meteorologists come in with their forecasts, and sometimes we're just in a little bit of denial. We just don't want to. We just don't want to believe what they say is going to happen is going to happen. No offense, Joe Charlevoix. So here is our investigative question. You will need to direct your attention on a PDF that I've attached for today's lesson. And you're going to have to record a couple of things today and for the next 9 days total for this lab. So that's a file, a document. You can either print it off and record information, or you can just keep using Cami and keep track of that information on that PDF on your Chromebook. We're going to take a look at what factors could help affect each other that would then allow meteorologists to know what's going to happen with the weather, to know how it's going to change. So although we're looking at the weather, the atmosphere, the conditions in the troposphere, our cross-cutting concept is cause and effect. How does one factor in the weather affect another? So the PDF looks like this on one side, identically, actually. This is a screenshot of it. And I would like you to type in the question. And although everybody has the same investigative question, you're going to pursue it in different ways because everyone can choose whatever two factors they think are affecting each other. And in case you're wondering if I've made a spelling mistake, apparently when affect is used like a verb, it has an A. But when it's a thing, a noun, down here in the lower right, it is with an E. So I know it looks a little strange, but I think Mrs. McGeorge would agree with me that my spelling is okay. Now pause the video at any point, come back to me. I'm going to keep going, but if you need a little bit of time to enter this on your PDF using Cami, or if you're printing a hard copy and writing, pause the video, come on back. So let's take a look at some possible cause and effect hypotheses people might have. One of the best forecasting factors about the weather is something called the barometer. The barometer is how much air pressure is pressing down above you. And that mile of air above you has so much mass that if you remember this little device in my classroom, it can actually push down on a column of water. This is an open system. There's a little hole here, in case you ever took a look at that in my classroom. And when there's a high barometer, we say there's a great deal of high atmospheric pressure, and that mass pushes down on the water in this little device, so much so that the water level is pushed down here. When there's low pressure lifting air, the water is allowed to creep up the neck of that glass spout. And in fact, we've had days where it's been really rainy, and we look at our little analog, old-fashioned barometer device here, and water is literally trickling out of this spout, suggesting extremely low barometric pressure. Little mnemonic device I like to use: high pressure, happy skies. It's by my son. And low pressure, lousy skies. It's a harbinger of rainy weather. So that's one cause and effect way to express that. Of course, there's other ways. We could use an if-then statement. If the barometer is dropping, then we will have rain. And maybe this whole air pressure thing doesn't interest you at all. Maybe you're more curious about wind and wind temperatures and wind directions. And that's the great thing about this lab. You choose. True to the spirit of inquiry, you'll see a bunch of variables on the left. Those are our independent variables. Pick one. And on the right are our dependent variables. Pick the dependent variable that you think is affected by the variable on the left. I'm going to give you some examples. And you could literally pick one of these word for word, or you can come up with something more creative on your own. But Pete Calcaterra had a real common one. He thought that the higher the barometric pressure, the sunnier the skies. If that's something you'd like to pursue, go ahead and write it down. Gabby Musser had the higher the temperatures, the higher the humidity, water vapor in the air. I thought that was an interesting one. Here's Brady's. If there are north winds, then there will be a colder temperature relative to the south winds. Notice I used a color code for all of these. The green matches the cause and the orange the effect, or the independent variable here and the dependent variable. And a fourth possibility, Angel had a cool one here. Higher temperature would make there be less clouds, fewer clouds. So you can pick one of those. You can use one of these four examples you've seen, or here's the cause and effect, the inquiry screen. You can pick one on the left that you think will cause a factor on the right. So at this point, please pause the video, go back, make a hypothesis, and do your very best to make it cause and effect. Welcome back. Now we're on page 2 of the PDF, and you'll notice I have available to you every variable that I could think of going from left to right. The next decision you're going to have to make is, where are you going to get your weather data every day for the next 9 days? I'm going to use AccuWeather, although I jokingly call it InAccuWeather sometimes because it gets really frustrating. It seems like it's fairly inaccurate more often than not. Feel free to talk to your parents. Where do you get your weather information? And, maybe they have some advice for you. But just to keep it simple, I will use AccuWeather. And when you get on their website, you'll see this is a pretty typical setup, regardless of the website. You'll see a lot of information here. You do not need all of this information. You only need a couple of pieces of information. First of all, in the top left, record the date. We're all starting on 5/26. Second is your source. I'm using AccuWeather. I don't care what source of weather you use, but I ask that when you pick it, stick with it and don't bounce around one day to the next to different websites. Now here is Pete's hypothesis. The only two things he needs to record today, tomorrow, and every day until we're done with this lab is the barometric pressure, that'll be a number, and whether or not the skies are sunny. And that'll be recorded as a %. He does not have to record, and you do not have to record everything else. Now, if we were all together, if we're not doing this remote learning thing, then we would. But trying to simplify it, strip it down here, and I'm only going to have you record those two factors, your independent and dependent variable on your hypothesis. All right, next one is Gabby Musser's. Gabby wanted to see if high temps would bring high humidity every day. If that's your hypothesis, you would record the temperature and the humidity, which is expressed as a percentage. Mr. Budka was wondering if north winds are colder. He will record the temperature every day and the wind direction, which will sound like a compass bearing. And then the final example I gave you, Angel wanted to know if high temperatures would cause less cloud cover. You know where this is heading. She's recording the temperature and the cloud cover. And she, actually, you, if that's something you're interested in and that's your hypothesis, would not have to fill in every other gap. So, if you've gotten this far, you're done with your weather lab today. Every day for the next 9 days, as meteorologist Mike Wilson is pointing out here, I will remind you to record your weather data, just your independent and dependent variable, and try to make it the same time of day. That would be helpful. Whatever is convenient for you. Maybe it's the first thing you do in the morning. Maybe it's the last thing you do in the morning. And we'll keep track of if your variables are affecting each other at the end of our 9 days. Thanks, everybody.